Hi guys, today I'm going to work through the worked examples from exercise 3.8, which is literal equations. So this is of course from your Year 12 Jacplus textbook. So let's start with worked example 15, and we've just got to solve for x. So this one's actually pretty easy, and you probably would have seen quite a few things like this in Year 11. So I'm just going to get the x's all on the left hand side. So mx minus kx equals equals negative z minus ny, and then I can take the x out here. So I factorise to x, open brackets, m minus k, close brackets, and that still equals that. So now I can just divide everything by m minus k, and I get x equals negative z minus ny over m minus k. And look, you can put that into a variety of different forms if you so wish. So I could take out a negative 1 here, z plus ny over m minus k, sorry. And that would mean, well, I could just put the negative out the front. Or I could put it as z plus ny over, make the bottom negative, which would be k minus m. So look, any of those, this is fine, this is fine, and this is fine. And I guess the point is that if you had a question like this, I would sort of think it would be a multiple choice question. So you might not realise that what you found is in just in a different form. So just make sure you know how to manipulate them. The next one looks a little bit harder. It involves addition and subtraction of fractions. So that means we need a common denominator. So my common denominator would be m plus x. Okay, and then what you do to the bottom, you do to the top. So I'm timesing by m plus x, so p m plus x. I'm timesing by x, so 2mx. I'm timesing by m plus x, so 3y, m plus x. And now that I've got a common denominator and I have, done what I do to the bottom, I do to the top, it means I can cross out the denominators. Of course, there's an equal sign there, so that means I can do that. And I'm going to expand pm plus px minus 2mx equals 3ym plus 3yx. And we're still solving for x, so we're going to need the x's over the left and everything else over the right. So px minus 2mx, so these will keep on this side, and we want this over here, minus 3yx, and I want these over the other side, 3ym minus pm. Okay, so now again I'm just going to take the x out. And then we'll just divide by p minus 2m minus 3y. So x equals 3ym minus pm over p minus 2m minus 3y. And when you get to this stage, you want to check whether you can cancel anything down, factorise anything. It doesn't look like we can, so that would be our final answer there. So we can't like take out an m on the top and the bottom and cancel it out, for example. So if we could, we would do that. So look, let's look at the next one, and these simultaneous ones are a little bit more involved. I would say quite tricky. So just like you would do normal simultaneous, you want to eliminate something, and I'm going to multiply this by m. So that means my first equation, actually I'll do the multiplication first, m times x is mx, m times ny is mny, and m times 2d is 2dm. So now I'm going to put, well, I might write the other one on top. And then now I can subtract these two equations, and I will eliminate the x, mx minus mx, that will go. So negative y minus mny is negative y minus mny. So it just stays like that, equals k minus 2dm. And what you can see here is that, well, if we take the y out, we get negative 1. Be careful, it's negative 1. It doesn't just disappear. Minus, sorry. mn equals k minus 2dm. And well, now we can solve for y. So y equals k minus 2dm over neg 1 minus mn. And look, this is quite yuck here. I'm going to take that negative out. So I'm going to get y equals k minus 2dm over negative 1 plus mn. And of course, well, I can put that out the front there, which makes it, well, I guess ultra neat. So there's our value for y. So simultaneous equation, we have x and y values. So we've got the y value, which I'll write there, negative k minus 2dm over 1 plus mn. And of course, I don't need the brackets there. It's under the vinculum, so it is in brackets. So look, we've got the y value, and I think it's convenient to write it like this because then you know that you still haven't solved for x. And if you were doing a normal simultaneous equation, I think you wouldn't ever forget to solve for both variables. But in something like this, it's quite plausible to do so. So now I need to choose where I'm going to sub in this this y value here in order to find x. And I think it's probably best to do that one. You can do either, just like normal simultaneous, but I reckon this one's going to be best. So let's do that. mx minus y is negative k minus 2dm over 1 plus mn equals k. So these will cancel to become a plus. mx plus k plus 2dm over 1 plus mn equals k. All right, let's minus this thing on both sides. So mx equals k minus k plus 2dm over 1 plus mn. And then I'm just going to divide by m on both sides. So x equals k over m minus k plus 2dm over 1 plus mn and timesing by m. So look, this looks a bit messy to me. It's not wrong, but I feel we should really make a common denominator between the two. So I'm just going to multiply by 1 plus mn on the top and bottom, of course. And that will give me x equals k 1 plus mn over m 1 plus mn minus k plus 2dm over m 1 plus mn. And well, now I can put them all over the one vinculum, and I'm going to expand this. So this will be k plus kmn minus all of this, by the way, not just the k, so minus k minus 2dm over m 1 plus mn. And now, well, let's neaten this up. K minus k is 0. So x equals kmn minus 2dm over m 1 plus mn. And this is the part where you want to check if you've got a common factor here, and actually we do, so it's quite nice. We can cancel the m from all of these. If there was no m here, you couldn't just cancel the m from two of them. It has to be in everything, so just be careful of that. I think you would already know that from year 11, but just to be sure. So our x value is kn minus 2d over 1 plus mn. Kn minus 2d, so kn minus 2d over 1 plus mn, I think. I'll just double check. Yep, 1 plus mn. So there would be our x and y values. So I think that's particularly tricky. So you might want to practice more of those ones because they're quite difficult. And that completes all the examples from 3.8.